Hello everyone. In this video, we are going to discuss about the discriminant of a quadratic equation and how it is related to the nature of roots of the given quadratic equation. So we all know that x equals to minus b plus or minus square root of b squared minus 4ac by 2a is the quadratic formula that we use to find the roots of a quadratic equation where a must not be equal to 0. Now the expression which is inside the square root is called the discriminant. That means this expression here, b squared minus 4ac. This is called the discriminant of the quadratic function. The discriminant determines whether the quadratic equation has two distinct real roots. That means if b squared minus 4ac, this expression is greater than 0. So it is like 4, we get 4, which is greater than 0. Then we are going to have two distinct real roots, two equal real roots, which is also called as repeated roots or equal roots. So that we would get if b squared minus 4ac is equal to 0. So when we substitute the values of a, b and c and we get a 0, then we are going to get two equal real roots. And the last one is no real roots, or also called as imaginary roots or complex roots, if b squared minus 4ac is less than 0, something like this, minus 4 less than 0, because if you put minus 4 under root, this becomes imaginary, right? So we see no real roots. Let's see a few examples. Find the discriminant of the quadratic equations and hence find the nature of its roots. So first we need to find the discriminant and then we have to find the nature of its roots. So here it's given in the form of ax squared plus bx plus c equals to 0, where a equals to 2, b equals to minus 6 and c equals to 3. Now using b squared minus 4ac, we find out the discriminant first, substitute the values of a, b and c, and then when we simplify we get 12. 12 is greater than 0, so the given equation has two distinct real roots and we can easily find the roots using the quadratic formula, which is minus b. So minus b here is minus 6 plus minus square root of the discriminant, which is 12 over 2, a is 2. Now if I solve this, minus minus plus 6 plus a minus, and for 12 can be written as 12 is 2 times 3 times 2. 3 2s are 6, 6 2s are 12. So this can be written as 2 root 3 over 4. Now just cancel out the common factor, which is 2. So this will become 3 plus or minus root 3 over 2. So this is going to have two solutions, 3 plus root 3 by 2 and 3 minus root 3 by 2. So two distinct real roots. Now let's see the next example. 3x squared minus 2x plus 1/3 equals to 0. So a is 3, b is minus 2 and c is 1 by 3. Again using the discriminant, we find the value of that, which equals to minus 2 minus 2, 4 minus 4, and here in this case it becomes a 0. We know that when the discriminant is equal to 0, the equation would have two equal real roots. So for this one, we're going to have two equal real roots. Now you can same way use the quadratic formula and find it out. So here in this case, x would be equal to minus b by 2a, because plus or minus this discriminant thing, this is eliminated because this is 0. So this we don't need, just simply minus b by 2a, and you can say minus 2 by 2a. So that's 2 times 3. This becomes 2 by 6, or we can say 1 by 3 and 1 by 3 are the two roots of this given equation. Okay, now let's see the last example. And the last one is 2x squared minus 4x plus 3 equals to 0. Here a equals to 2, b equals to minus 4 and C equals to 3. Same way we find the discriminant and we get minus 8 in this case. So minus 8 is less than 0. So the given equation has no real roots. Okay, so we can say that if the discriminant is greater than 0, then we would have two distinct real roots. If the discriminant is equal to 0, then two equal real roots or repeated roots. And if the discriminant is less than 0, then no real roots or imaginary roots. I hope this is clear to all. Thank you.